This is 1f, and this one's got it's kind of got multiple layers. So first off, I do need to integrate x e to the x, which that is going to take some integration by parts, and tabular method works pretty well. And then also, notice it's got that infinity, so we're going to have to do some limit work as well. So let's get started. I'm going to first work out my integral. I'm going to use integration by parts, tabular method. On my dir side, I get an x. On my int side, I get an e to the x. So when I dir, I get 1 and then 0. And then my integral of e to the x is always just e to the x. So at least that part's nice. So I get a plus and a minus. So I get, here's where I have to introduce this limit notation. And I think one of the more recent videos, maybe the last one, I said we often talk about integral from a to b. Since I'm going to sub out this negative infinity, I'm going to use an a in my limit notation. You could use a b, totally fine, but whatever works for you. So this is the limit as b goes to negative infinity of, all right, now what I'm going to do is open a bracket, because I know I'm going to have multiple terms and I want to be able to see it well. But I have the diagonal multiplication that we get with tabular method. So what I get is x times e to the x, and then minus e to the x. And that's evaluated from a. Oh, look at, I just messed it up. So why I say b? I'm going to stick with a, like I said I was going to. Sorry if you were to b and had to erase. And then out to 0. And I'll quickly comment, why don't I have a limit notation for the 0? Well, I can plug in 0 for either one of these functions, and it's no problem. There's no limit issues or anything like that. So my next line, we are going to go ahead and plug in the 0 first, and then we're going to plug in the a, because that's the upper bound. So I don't actually need to use my limit notation for the upper bound. So I get 0 times e to the 0 minus e to the 0. And then I get minus, because that's the lower bound, limit as a goes to negative infinity of, I'm going to open a bracket now, and I wind up getting a times e to the a minus e to the a, and then close. And now I want to talk about, well, let's deal with this first. So this is 0 times e to the 0 is going to be 0. The e to the 0 is 1, but then multiplying it by 0 gives me 0. And then I get minus e to the 0 is minus 1. And then I get minus limit as I'm going to write a goes to, and now in order to make this just a little bit easier to see, I'm going to write a goes to infinity. Whoops, that's an a, not an infinity. Goes to infinity of, and I'm going to move my negatives in. So negative a times e to the negative a minus e to the negative a. Close. All right, so let me talk about this for a moment. E to the negative a, as a goes to infinity, well, that's exponential decay. And what happens is this goes to 0. Yeah, right, goes to 0. Goes to 0. So I'm going to wind up getting negative 1. And then I'll get these two terms here. So that one gives me 0. And then look, this gives me negative infinity times e to the negative infinity. Now, you should know that an exponential decay, this right here would be the same as, I'm going to use bad notation here, negative infinity over e to the negative infinity, or limit as x goes to infinity of x over e, sorry, I'm going to fix this, e to the x. This negative is exponential decay. I could pop it to the bottom and make it a positive. So I've got something that's going to infinity over something that's going to e to the infinity. The e to the infinity is way, 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 way bigger. So what happens? This whole thing also goes to 0 because I've got a way bigger denominator than I have in the top. So this also goes to 0. So what I wind up getting is I get 0 minus negative 1 minus this limit is going to give me 0 minus 0. So all these things, just a lot of them wind up zeroing out, and I just wind up getting -1 for my answer.